Okay, so this section is about the hypothesis test about the population mean. Okay, so this is the so this main title of this section is hypothesis test about a population mean, and the most important the core, right? The core of this section is basically everything. The core of this section is really summarized in this table, right? Basically the summary of a hypothesis test about population mean. As you can see, there are three different cases: lower tail test, upper tail test, and two tail test, right? And for each test, right? For each test, you need to think about the three things: hypothesis and test statistic and p-value, right? The three things. Okay. So now, before we get into this detail of each case, let's briefly talk about steps of hypothesis testing. The first step is you need to develop a null and alternative hypothesis, which is this, right? For each case, right? Okay. And then you specify the level of significance, right? Okay. So basically, so let's just write this down. So first, you need to develop what? And I mean, for every cases, right? You need to develop the null hypothesis and alternative hypothesis, right? And then you need to, step number 2 is you need to define the alpha, which is level of significance. As a researcher, right? And this is the value. Let's say you are a researcher, right? And this is the value that you need to decide before the testing, right? The level of significance. Example is like, is that time is going to be the alpha, also is known as what? Level 1, type 1, sorry. The type 1 error, right? Okay, so you need to decide the alpha, whether it's going to be 10% or the 5% and etc., right? So that's something that you have to decide. And step number 3 is to collect the sample data and then compute the value of the test statistics. Okay, so now you have a you need to collect the sample data, right? Sample, right? It's going to be random sample of size n, right? And from that sample data, you need to calculate the test statistics, right? Statistics, and then, okay, let me just write this down. Okay, so you need to develop the test statistics, right? And which is a t, it's known as a t, right? And then t is, the formula for the t is the, as you can see in the table, right? The t is x bar minus mu naught, right? And standard error, right? Standard error for the sample distribution, okay? So t, and then you know that this is, let's say for the lower tail, you know that null hypothesis is going to be population, the mean is greater than or equal to mu naught, some value, right? Or in the upper tail case, it's going to be less than, right? I mean, the mu is mu is less than, and then for the two tail test is equal, right? An alternative hypothesis is less, greater, and then it's not, right? This is for the lower tail, upper tail, and two tail, right? But anyway, so this mu naught, right? For each case, you have a mu naught. Okay, so to calculate the test statistics, from the sample, right? From the sample, let's say you have a populations, and the population has the mean u, right? And you get the sample, right? So this is like a sample and sample size of n, right? And from this sample, you can compute the sample mean, right? Okay, so from the sample mean, I mean, we know that this is a sampling distribution of the sample mean, right? So this is a sampling distribution of sample mean, right? And if we assume that null hypothesis, right, is true, like for in such a case, we know the center of this sampling distribution of the sample mean is first the normal distributions, and the center of this sampling distribution of the sample mean is mu, right? If null hypothesis is true, right? Okay, so from that, right, we know that the standard deviation of the sampling distribution, right? Standard deviation of the sampling distribution is S means the sample, right? Is what? The sigma, right? The notation, right? Okay, so standard deviation of the sample, the notation is this, right? Standard deviation of the sample distribution is, we know that this is what? The sigma, right? Like this is population standard deviation and root n, right? So it's known as a standard error, right? So this is a standard error, right? Okay, but we don't know the population standard deviation, right? So you know that this can be estimated, right? So this is going to be, since we don't know this, so this is going to be replaced by S, which is the standard deviation of a sample, right? So the notation that we need to use is what? Hold on. Basically, the notation, right, is that we need to use is basically the S, the standard error is, this is the estimated by, this is the notation for the standard error, right? And now S root n, right? So this is a standard error. By the way, this is approximation of sigma x bar, right? So now we use S x bar, right? Anyway, so this is something that we learned. Okay, so to find the t statistics, right, we need to use this equation. So from the sample, we can get the sample mean, right? We can get the sample mean from the sample, right? And then we have a mu naught from the null hypothesis, right? Null hypothesis for the mu naught, and divided by what? The S x bar, right? Which is the estimate, like standard error, right? So this is like estimated standard error, which is this value. Okay, so we expand this t value a little bit, so we can have what? X bar minus mu naught, right? And divided by S divided by root n. Okay, so that's the test statistics. So this is step number 3, right? And then step number 4 is what? Step number 4 is, let's see, what is the step number 4? Let's look at the textbook. Okay, so standard number 4 is the use the value of the test statistic to compute the p-value. Okay, so from the t, right? So now we know the t, right? And so from t we can calculate the p-value, right? So from t we can calculate what? P-value, right? And then step number 5, from p-value we calculate the step number 4 if we reject, right, null hypothesis if the p-value is less than or equal to this alpha, right? This alpha value. Okay, so that's the step 1 through 5, right? And then the number 6 is, of course, the interpret the statistical conclusion. Okay, now let's talk about a little bit more about this p-value. Okay, so the p-value, right? Definition of p is basically the probability, right? Okay, So the definition of the P is what? The p-value, definition of the p-value is the probability, assuming that H naught is true, null hypothesis is true, right? So basically, probability of obtaining random sample size of n that result in a test statistic, at least as extreme as, so important word is at least, right? At least as the extreme as the one observed in the current sample, right? So it could be extreme. So at least means it could be as extreme as the one observed in the current sample, or even more extreme, right? So that's mean by the p-value, right? Okay, so that's the formal definition of the p-value, right? But what is like informal definition? Like we need a little bit more intuitive definition of the p, right? Okay, so just let me explain this p-value, right, using a graph, like a diagram, okay? So, so the graphically, right, the graphically what the p-value means. So first, okay, first we know that p is probability, right? You know, from the t, by calculating the t, the test statistics, right? Okay, so now that's like a basic concept, right? But graphically, right? Graphically, it can be easily understood, okay? So now let me just draw the graph. So first I'm going to draw the lower tail test, right? And then I'm going to draw the upper tail test, right? And then finally, the two-tailed test. Two-tailed test, right? So we have the three different cases, right? Okay, so now let's just, for the lower tail case, you know the null hypothesis is what? The mu is greater than or equal to mu naught. And then alternative hypothesis is mu or less than, right? This is less than the mu 0. And then for this, mu is this, right? And make sure that there's an equal sign. And then alternative hypothesis is a population what? The mean is greater than certain value, right? And the two-tailed test is the mu is equal to mu naught, the population parameter, right? And then alternative hypothesis that population parameters is not equal to mu naught. Okay, so that's the two-tailed case, right? So now let's talk just through the graph, right? I mean the diagram, the normal sampling distribution of a sample mean. Okay, first lower test. Okay, so that's a lower test. So okay, so let's see. And then let me just draw. So this is normal distribution, and then finally we have a third one, right? Okay, so we in the step number 2, right? We need to decide alpha, right? So let's say we assume that the null hypothesis is true, right? So we know that this is first, our assumption is that null hypothesis is true for all three cases. Okay, so that's our assumption. That's the assumption that we need to begin with. So that means the center of the sampling distribution of a sample mean is mu here, population mean. Same for three cases, because we know that we assume that our starting point is our null hypothesis is true, right? So that means sampling distribution of the sample mean follow normal distribution whose center is mu, right? Okay. And for every cases we have alpha, right? So this is our alpha. You know what? Let me just draw the different color. I'm gonna use the let's say, okay, purple. So we know that we have alpha, right? So this is the alpha, the level of significance, right? So level of significance is what? You know, this tells you how far, right? This indicates the distance from the mean, right? This tells us that how far is really far enough, right? So that's really what alpha is really all about. So alpha, right? And alpha. And then we have alpha. And then we have alpha, right? Okay, so that's like we're standard. This is our starting point, right? So this is something as a researcher, you decide the alpha value before the testing. Now, we calculate the test statistics, right? So we calculate test statistics and we reject null hypothesis, right? We know that if the t value is in the lower case, right? In the lower tail test case, when you know that t value is in this rejection area, right? So we know that this yellow area is a rejection area, right? And for the upper tail case, rejection area is here. And then for the two tail case, our rejection area is here, right? Okay, so that's for the two tail case. Now, so p-value, right, really represent graphically is in the lower tail case, the p-value is the probability. So it's area underneath, right? Underneath this, starting from the t, right? So the starting from the t, so as small as so basically the probability under this area, right? And for the upper tail case, right? Okay, for the upper tail case, let's say your statistics, your t value, right? Your test statistics lie in this rejection region, right? Then you reject a null hypothesis because it's too far away from the mean, which means a strong evidence, right? Strong evidence that the null hypothesis is false. Okay, so let's say you have t value here, right? So the p value is the area underneath, right? So this is like a red area is your p value. And this is your p value, right? Okay. And for the two tail case, right? In the two tail case, you need to let's say you calculate t value, right? And if your t value, let's say let's say this is your t value, right? And you know that normal distribution is symmetric, right? So your p value actually is, you first calculate, assuming that t value is in the right tail, right? In that case, let's say this is your t value, right? To use a red. Okay, so this is your t value. So you reject, first of all, this t value is in this rejection region, you reject a null hypothesis, right? In this case, but you calculate this area, right? But at the same time, since it's a two-tail area, you know that this is what? This is minus t, right? And then you need to also compute this area. So basically what you need to do is, let's say this is area, right? This is some area. So your p-value in this case is what? 2 multiplied by that red area. So this area, okay? So 2 multiplied by area. So that's the probability, and that's the basically p-value for the two-tail case. Okay. So for the two-tail test, right? Make sure that you calculate this t-value. I mean this this area, right? Either left or right. So you know what? I'll just say to be more precise. I just want to say area. I just want to say, let's say this is right area, right? And then you know that this is left area, right? So your p-value is what? Either 2 multiplied by right area, or the same as 2 multiplied by left area. Okay, so that's your p-value. Okay, so that's the graphical representation of the p-value, right? So if that p-value is less than your level of significance, then you reject the null hypothesis, because what? Your t-value is too far away, right, from the mean, right? So it's really indicate that your null hypothesis really cannot be true. Okay, so now that's the graphical representation. Now let's take a look at the p-value in more detail. Okay. Okay, so what's the small p-value really means? The smaller p-value indicates that it is less plausible, so it is less likely that the sample could have been collected from a population for which the null hypothesis is true. Okay, so that's what the small p-value really means. Okay, okay, so in general, right? In general, what small p-value, right? Small p-value means what? It is less likely, right? The small p-value means it's less likely that the sample, right? We got the sample, right? From the population, we got the sample, right? So this sample, right? The sample could have been collected, right? From the population for which the null hypothesis is true. Right? Okay, so the important thing is it's less likely, right? It's less likely. Okay, so you know what? In general, right? If the p-value is really small, right? So if you just, okay, so if the p-value is really small means, let's say in the left tail case, okay, let's say this is center, right? Mu, this is center. And if the t-value is small means it's really like, in the lower case, it's really far away from the mean, right? That means your p-value gets smaller. And for the upper tail case, when your t statistic value is really like far away from the mean to the right, that means your p-value also is decrease, right? Your p-value gets smaller. So that means it's less likely that the sample could have been collected from a population for which the true null hypothesis is true, right? So your population, right, could not have this mu, this population mean. So that's what the small sample value really means, and that's why you reject a null hypothesis, right? You reject a null hypothesis, the p-value is very small compared to this alpha, okay? Okay, so another interpretation, right? Another interpretation is like, this is like another interesting interpretation. So I want you to look at what the p-value means in a very different aspect, very different angle. So let's see. Okay. Okay, so another interesting, the smaller p-value indicate more evidence against a null hypothesis, right? So this is very important. Smaller p-value indicates what? More. So this is like another interesting definition of the smaller p-value, right? So the smaller p-value means what? Indicates what? More strong evidence, right? More evidence against, so you can say or you can say stronger, right? The stronger evidence against what? Null hypothesis, right? As they suggest what? They suggest what? It is increasingly more unlikely, right? It is increasingly, I know it's English is increasingly more unlikely, right? So important here is what? Unlikely, right? It's more unlikely that what? That the sample could occur if H is true, right? So basically, if the null hypothesis is true, right? It's unlikely that we're going to observe this T that is this far away from the mean, right? If null hypothesis is true, your T value is kind of should be very close to this mu, right? But in reality, right, what you observe is you observe a T value which is really far away from the mean. So that suggests that what? It is increasingly more unlikely that the sample could occur, right? So it is increasingly more unlikely that you are going to observe this T value this far away from the mean. Okay? So that's what really a small P value means. And that's why when you have a small P value less than alpha, right? And you reject the null hypothesis. Okay? So that's the basic idea. Now, then how can you get the P value using Excel spreadsheet? I mean, typically, yes, you can get the this P value by looking at the T distribution table, right? But in this class, I want you to use the Excel spreadsheet, right? Okay, so for that, you should use T distribution functions, right? So in the lower tail case, you have to use a T dot distribution functions and this upper tail and two tail. Okay, so now for the P value, right? Okay, so for the P value, okay, so in the lower case, to get the P value, you have to use T dot distribution T, right, comma n minus 1. You know, n minus 1 is the degree of freedom, right? The sample size minus 1. And then the true means, yes, it's cumulative, okay? So if you use these functions, then you can get this red area, the P value, okay? So you can get the P value. You know, this is left area, right? Okay, now for this the upper level upper tail test case, right? So for the upper tail test, let's see. Let me just I want to make this window a little bit big, and then oops, then move down. Okay. So for the upper tail case, this P value, right? To get the P value, right? This area, right? This area, the P value is just 1 minus T dot distribution, right? T n minus 1, right? And what? True, right? So the reason that it's 1 minus 1, actually this value, right? This one, since this one is cumulative, right? What happened is this blue one, right? Basically, it returns this blue area, right? So basically, 1 minus this blue area. Oops, actually up to here, right? So since this is your T value here, and by the way, this T value, you plug this T value here, right? T value. Right, so this T value you plug in here. Okay, so this blue area, 1 minus this blue area, and you have this red area. So graphically, so this is your P value, right? Red area, this P value, red area, right? Is 1 minus this blue area, right? Okay, and that's why you can get this red area, the P value. Okay. So now let's take a look at the two-tail test case. Okay, so this two-tail case, let's see. I have to move back. It's 2 times, right? Okay. So in the two-tail case, right, it's 2 multiplied by right area, right? So what you can have is, let's see. Okay, so 2 multiplied by right area, and so basically, if you look at the textbook, they kind of use this 2 multiplying mean. They apply the mean functions and all that, right? But actually, I really don't like this this notation, right? This formula. So instead, let's just use some intuition, right? So we know that the p-value is 2 times either what? 2 multiplied by right area, or it's 2 multiplied by left area, right? So that's your p-value. So what you can do is, once you get the statistics, right? Let's say once you get the statistics, and once you calculate this right area, you just multiply by 2, right? If your t-value is a negative, right? If your t-value is a negative, I mean, this is like example, like if your t-value is negative, in this case it's this case, right? And so this is like, it should be the negative, right? I mean, it's not the, it's a negative, right? Because, this is a t-distribution, by the way. This is a t-distribution. We have to assume that this is a t-distribution, right? So that means here is a 0, right? 0. Right? So assuming that we convert this normal distribution to the t-distribution or the z-distribution, if the normal distribution is like either z or the t, we know the center is what? Is a 0, right? So we know that this is negative. So when the t is a negative, like this, we can simply, the p is 2 times left area, which is this guy, right? So t times distributions, and then we plug this t value, right? We plug this t value here, and then n-1 and then true, right? Okay. And when the t value is a positive, right, then we still can use this value, right? So we just put the negative value, right? And then we can calculate, so for example, if the t is positive, right? And basically, actual equation is p is what? 2 multiplied by this, right? Which is 1 minus t dot, right? T dot distribution functions, right? So I'm gonna skip the rest. Okay. So when the t is a negative, you can use the p is equal to 2 multiplied by this, which is this guy, right? And when t is a positive, then we can use 2 multiplied by basically this one, right? 1 minus t dot distribution t n-1 true. Okay. So basically that's how you can get the t value. Okay. So I mean, that's really everything about the populations. Everything about the hypothesis test about a population mean. Okay, so thank you.